Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the adding and subtracting of polynomials. Before we do, let's look at a definition of polynomials. So a polynomial is an algebraic expression composed of the sum or difference of monomials, expressions with one term. Polynomials cannot have variables in the denominator fractional exponents or negative exponents. So let's look at some examples of polynomials, and let's look at some things that are not polynomials and talk about why they can't be polynomials. So an example of a polynomial might be something like 4x plus 2. Notice we have a monomial, 4x, and another monomial, 2, and they're combined with addition. Or we might have something like 3x squared minus 2x plus 5. So here we have 1, 2, 3 monomials combined with subtraction and addition. So these are examples of polynomials. Now, something that could not be a polynomial would be like, I don't know, 8. I wanted to do that in blue, sorry. 8 over x plus 2. Yes, we do have two terms that are combined with addition, but a polynomial cannot have a variable in the denominator. So that would not be a polynomial. If you had something like 5x to the 1/2 power minus 3. Yes, that's a monomial minus a monomial, but a polynomial cannot have a fractional exponent. And finally, if you had something like 4x to the negative 2 power plus 5, that would not be a monomial either because there's a negative exponent. Now, when we're working with polynomials, we can add them, subtract them, multiply them, divide them. But today we're only looking at adding and subtracting. So for adding, all you do is you identify the like terms, and then you add the coefficients of those like terms. Now, subtraction has an extra step. So subtraction can be defined as addition of the opposite. In other words, every subtraction problem can be rewritten as an addition problem. So in 7th grade, you learned that 4 minus 7 is the same thing as 4 plus negative 7. It's the same exact problem. It's just written as addition of the opposite. So when subtracting polynomials, we use the same concept. We rewrite the problem as an addition problem by adding the opposite of each term in the polynomial that comes after the subtraction symbol. Now let's look at a few examples. So in example 1, it says find each sum or difference. So that means we'll be adding and subtracting in these problems. So in problem A, we have 4x plus 2 is our first polynomial, plus 7x minus 5. That's our second polynomial. So this is an addition problem. So to add two polynomials, we simply identify the like terms and then add their coefficients. So if I were to identify the like terms, 4x and 7x are said to be like terms, and the 2 and the negative 5 are said to be like terms. So I'm simply going to take the 4x plus the 7x and add the 2 plus negative 5, and then rewrite this as one polynomial. So 4x plus 7x is 11x, and 2 plus negative 5 is negative 3. So we would write negative 3 as minus 3. So addition of polynomials is pretty straightforward. Where you have to be careful is with subtraction. So in problem B, we have 3x minus 7 minus 2x minus 4. So when we subtract two polynomials, the first thing we have to do is rewrite it as an addition of the opposite problem. So if I were to rewrite this problem, I would not do anything to the first polynomial. I would change the subtraction to addition and then take the opposite of each term. So this would be negative 2x, and the opposite of minus 4 is plus 4. Now, what we have now is just an addition problem. So we're going to do it just like we did before. We'll identify the like terms and then add their coefficients. So I'm going to take 3x plus negative 2x plus negative 7 plus 4. Then you simplify it. 3x plus negative 2x is just 1x. Negative 7 plus 4 is negative 3. So again, I would write minus 3. All right. Now, sometimes we can have longer polynomials. If you look at problem C, we have 6x squared plus 3x minus 5 plus negative 4x squared plus 4x minus 12. So this is an addition problem. So we don't need to rewrite anything here because we're just adding. So I want to first identify the like terms. 3x and 4x would be like terms, and then negative 5 and negative 12 would be like terms. So this time I'm going to need 3 parentheses. So I'm going to put 6x squared together with negative 4x squared. Then I'll put 3x together with positive 4x. And then I'll put negative 5 together with negative 12. Now, we're just going to simply simplify all those. So 6x squared plus negative 4x squared gives me 2x squared. 3x plus 4x gives me 7x. And negative 5 plus negative 12 gives me negative 17. So minus 17. All right, problem D. 8x squared plus 5x minus 7 minus negative 5x squared plus 7x minus 10. So this is a subtraction problem. So before we start it, we need to rewrite it. Don't do anything to the first polynomial, okay? Just write it down. Now change the minus to a plus, and then take the opposite of every term. So the opposite of negative 5x squared is positive 5x squared. The opposite of 7x is negative 7x. And the opposite of negative 10 is positive 10. Now, what I'd like you to do is pause the video and finish this problem on your own. All right, welcome back. Let's see how you did. So I identified my like terms as my first step. And then I grouped them together. So I put 8x squared with positive 5x squared. And then I put positive 5x together with negative 7x. And then I put negative 7 together with positive 10. And I got, as my final answer, 13x squared minus 2x plus 3. All right, if you need to make any corrections, pause the video and do so now. If you got the problem right, let's continue on to example 2. In example 2, it says simplify each of the following and write all answers in standard form. Now, here's what standard form means. The largest power goes first. So, in problem A, I want you to notice that these polynomials are written a little bit out of order. We have 10 plus 7r minus 3r squared plus negative 6r squared minus 18 plus 5r. So what I want you to do in that first parenthesis is identify the largest power. And in this case, it would be the negative r squared because the 2 power is the largest power. Now, identify the largest power in your second polynomial. All right? We'll put those are like terms. Now, our next largest power in the first polynomial is the 7r. And so I will highlight the 5r in the second polynomial in pink. And then in yellow, I'll put our constant terms, our 10 and our negative 18. Now, once you've identified your like terms, now we can combine them with addition. So negative 1r squared plus negative 6r squared would be negative 7r squared. So see how I put the highest power, the largest power first in my final answer. Then I put the next largest power, which is the r to the 1 power. So 7r plus 5r is 12r. And then 10 plus negative 18 is negative 8. Final answer. All right, problem B. We have 7x squared minus 3x minus 5 minus 8 minus 3x squared minus 4x. Now, notice this is a subtraction problem. So remember, for subtraction problems, we have an extra step. A lot of students try to skip this step, and it always causes them problem when they do. I need to change the subtraction to addition and take the opposite of each sign in that second parenthesis. So this would become negative 8, positive 3x squared, and then positive 4x. All right, now let's identify our like terms. So in my first parenthesis, my largest power is 7x squared. And that would be combined with the 3x squared in the other parenthesis. My next largest power is the negative 3x, and that would be combined with the positive 4x. And then my next one, final one, would be my constant terms, negative 5 and negative 8. All right, so I'm going to take 7x squared plus 3x squared. Well, that gives me 10x squared. Then I'm going to take negative 3x plus 4x. That gives me positive 1x, so just plus x. And then negative 5 plus negative 8 gives me negative 13. All right, problem C. We have 2x squared plus 4x minus 6x squared minus 3 minus 6x. What I want you to notice in this problem is that we have addition and subtraction. So for the subtraction, we're going to have to rewrite everything after the subtraction symbol. So I'm going to rewrite 2x squared, rewrite the plus 4x. Don't do anything to those polynomials. But then I need to change the subtraction to addition and take the opposite of everything in the second parenthesis. So that'd be negative 3, positive 6x. All right, now let's identify our like terms. So I have a 2x squared and a negative 6x squared. Then I have a positive 4x and a positive 6x. And my only constant term, wait, I wanted that to be yellow. My only constant term here is negative 3. So let's start with our x squareds. 2x squared plus negative 6x squared is negative 4x squared. 4x plus 6x gives me positive 10x. And then the only thing we have left is minus 3. All right, problem D. 5RT minus 3RW minus 8TW minus 6RT minus 4RW plus 2TW. So first thing I want you to notice is that we do have a subtraction problem. So that means before we can do anything, we need to rewrite. So I would write pretty small on this one. 5RT minus 3RW minus 8TW. Change the subtraction to addition, and then take the opposites. So negative 6RT, positive 4RW, and negative 2TW. Now we will identify our like terms. So 5RT, negative 6RT would go together. Negative 3RW would go together with 4RW. And negative 8TW would go with negative 2TW. So 5RT plus negative 6RT is negative 1RT. So just negative RT. Negative 3RW plus 4RW is positive 1RW. So just RW. Negative 8TW plus negative 2TW is negative 10TW. All right, in our last example, it says find the perimeter of the triangle below. Now, to find the perimeter of anything, we just add all three sides. So I'm going to make a polynomial addition problem out of this problem. I'm going to take my first side, 3 over 2x plus 5 over 6, and I'm going to add that to my second side, 3x minus 1 over 6, and then I'll add my third side, which is 2x plus 1/3. Now, please don't let these fractions bother you. Just use simply, if you're uncomfortable with fractions, just use your calculator. But let's first identify like terms. So 3 over 2x, 3x, and 2x. So in my calculator, 3 over 2, side arrow, plus 3 plus 2. Now, there are no decimals in my original problem, so I don't want decimals in my final answer, so I'm just going to press my fraction button here to convert that, and that would be 13 over 2x. Now, let's identify our constant terms here, and we're going to add these together. So, 5 over 6 plus 1 over, oh, I'm sorry, that was negative 1 over 6. Got to be careful on the symbols there. Negative 1 over 6, side arrow, and plus 1 over 3. And that actually added up to a whole number, so positive 1. So plus 1. And this would be a final answer if we found an expression to represent the perimeter of the triangle. And that concludes today's lesson, addition and subtraction of polynomials.